Okay, 17. Find a complete set of values of m in terms of c, such that the graphs of y equals mx plus c and y equals square root of x have 2 points of intersection. Okay, so again, let's just draw a picture to see what's going on, right? So I mean, you have square root of x, looks like that. Yeah. So I mean, the straight line, first of all, is obvious that it can't be negative gradient, right? If it's negative gradient, then you definitely only intersect once, right? So it definitely has to be a positive gradient. So maybe options A and B are better. So 2 points may be something like this, right? If it's this, then it's 2 points, right? So if you go too high, you're screwed, right? If you go too low, then you only hit once somewhere here. Yeah. So you need to, be very delicate. Yeah. Okay. So 2 points of intersection. How do we find points of intersection? So now we do the algebra. Yeah. Once we have the geometric idea. So intersection, simultaneous equations. So equates mx plus c equals square root of x. What type of equation is this? Have a think. Yeah. So it's a quadratic equation, right? Because it's a quadratic in terms of square root of x, right? So therefore mx minus square root of x plus c equals to 0. So we've got to make sure that this quadratic has 2 solutions. Yeah? So we need 2 solutions. So what does that mean? That means discriminant is greater than 0. Yeah? But today, we still need one more condition. How come? Because it's in terms of square root of x, right? So if you want square root of x to have solutions, you've got to make sure your roots of this quadratic is positive. Yeah? You've got to make sure the roots of the quadratic is positive, because you can't do square root of x equals -3. I mean, that's just impossible. Yeah? So you need to make sure the roots of the quadratic are positive. So therefore, what was I going to say? Therefore, the sum of the roots, the sum of the roots needs to be positive. Yeah, needs to be positive. Good. And the product of roots also, the product of roots also needs to be positive. Yeah. Good. Okay, so let's deal with these conditions one by one. So delta greater than 0, so b squared minus 4ac, so b squared 1 squared, or negative 1 squared, minus 4mc or 4cm, that's greater than 0. That's greater than 0. Yeah? So 4cm, got it come right, 4cm is greater than 1. Smaller than 1, sorry. What am I talking about? Yeah, 4cm is smaller than 1. Good. Next thing, sum of roots greater than 0. So the sum of roots is, negative b over a, right? Negative b over a. So this would be, let me have a think. So 1 over m, yeah, because it's negative 1. Negative 1 over m is greater than 0. Yeah. So that means that m is greater than 0, right? Because if 1 over m is greater than 0, then m must be greater than 0, because positive divided by positive is positive. Yeah. So m is greater than 0. This means product of roots is greater than 0. That means that c times m, c over m, sorry, c over m is greater than 0. Good. Okay, so let's combine all these, stuff together, let's say. Yeah. So this means that m is less than 1 over 4c. Yeah, this is the first condition. M is greater than 0, second condition. Okay. And then if m is greater than 0, then c is greater than 0. This is the third condition. Yeah. Good. Okay. So seems like they don't really care about the c condition. Yeah. So we only have to think about the m conditions. So m is less than 1 over 4c, and then m is greater than 0. So therefore we have answer A.